The Disc and Washer Method Review by Gwen Marcott. We're going to start with the disc method. For a review, the way to find the volume is you have to integrate from A to B, and you have to do pi times the radius squared. For me, it helps when I think about it as almost like a loaf of bread. And I know Mr. Peterson has said this, but it's one of the things that helps me the most. So here's our first example. This one might be just a little bit harder because it's not rotated around the x-axis or the y-axis, which I always find a little bit harder. So first we're going to start out, of course, with our drawings. So we have a line at x equals 1. That one's pretty easy, just like that. Then we also have a line at x equals 6. So 1, 2, 3, 4, 5, 6. Just like that. Alright, next we have our line y equals 2x. So since we're starting at 1, it starts at 2. And then we have x equals 2x, so 2 to 4. Just going to approximate this. 3 to 6. 4 to... It's about 8. And this should be a line. So this is 6, so let's just approximate that. So, alright, we're going to rotate this around our line that we already have drawn, that is y equals 1. So I'm going to draw a little rotation symbol so that I can remember where it's rotating around, especially on these problems. It's easy for me to get it mixed up, so I like to draw it. So I'm going to draw what my cone is going to look like. It's kind of a cone shape. It's going to go like that. Our discs are kind of big. They're going to come like this. Yeah, that's good. Alright, next we need to figure out how to put everything into our formula, which is, remember, volume equals a to b, integral from a to b, pi r squared. So first we need to find where we're integrating between. This one is clearly defined by our two lines, x equals 1 and x equals 6. So we're integrating between 1 and 6. Volume. I'm going to leave the pi out here just to make it easier for ourselves. Then we have to find our radius, and sometimes this can be harder, in my opinion, on these problems. So I'm going to start by drawing a picture, and we're going this way, so it's going to be dx. So for this, it helps me if I just start looking at different points on the graph. So this is 2, 4, but our radius here is 3. This is 3, 6, but our radius here is just 5. So our radius in here must be 2x plus 1. And it's important for us, not plus 1, minus 1. Now it's important for us to remember to put a bracket around the whole thing, or parentheses, and square it all. And then never forget, of course, dx. Now this is the part, again, where you just have to integrate it. So this is a chain rule. So it's going to be, we can use u du if we wanted to. So u equals 2x du equals 2. So u squared, 2 over 2, 1 to 6, and then dx. So it's just going to be u to the third, 1/3 u to the third. We take out a 2 here, so it's also going to be 1 times 1/2 pi. From 1 to 6. So this is 1 6. U, remember, is 2x to the third from 1 to 6 times pi. And then we just have to plug it in. So 2 times 6, 2 times 6 to the third is 12 to the third divided by 6 times pi minus 2 to the third divided by 6. This time I do have my calculator. So 12 to the third is 1728 divided by 6 is 228 minus 8 divided by 6 times pi. So I'm going to do minus 8 divided by 6 times pi. We get 900.58590 with rounding. And that is our volume. Okay, next up we have the washer method, my personal favorite. And for a refresher, the volume is almost the same as the disk method. However, you have two different radiuses that you need to know the difference between. So volume is pi, integrated from A to B, and you have to do the upper radius, or the big R, squared, minus the little radius, or the lower radius, squared. And for this one, I kind of picture it as like a ring, or like a funnel, or a tube. I don't know, every picture looks different, and it always helps me to draw it. But let's get started. This is our last example for the washer method, and the thing that's different about this one is that it's rotated around the x or the y-axis instead of the x-axis, which in my opinion makes it a little bit more difficult. So let's remember that for this whole entire problem, we are going to be using dy, or everything is going to be in terms of y. So I have already drawn out our graphs for us, which usually would be the first step, but I already have it done just to save some time. And the next most important step is to draw our radiuses. So we have a radius right here, and then we have a radius right here. Remember, because it's rotated around the y-axis, these are in terms of dy. I'm just going to draw a little picture for this one so we can get our head wrapped around how it's going to look. Just like that. And then we kind of have it come like a circle in the middle, and then a circle around the outside, like a big ring or like a cup almost. So then we are able to put everything into our formula. So volume equals pi, and then we need to figure out where we're integrating between. Now remember, this is in terms of dy. So we can't be looking from here to here, we need to be looking from here to here. And we can see that they intersect at the y-coordinate 8. So and they also intersect, or they don't intersect, but we'll say for the sake of this problem that I forgot to say that it is also bound by the x-axis. Alright, so we are from 0 to 8. And then we have to find our big radius. So our outer radius, the outside of the ring or the outside of the cup, is this straight line, or x equals 2. From here on out, we need to remember that it's in terms of y. So it might seem like it gets a little tricky, but if we just really, you gotta kind of think it through. So from here, the radius is always 2 because this is a straight line. So we can just put 2 squared. From here, we have to be careful because our radius is not 2x squared. This vertical line here would be 2x squared, but we're going this way. So we have to take this equation and turn it into the right terms. So we're going to take y divided by 2 And then I'm going to square root both sides. So then we have the square root of y over 2. So then we can subtract the little radius, square root of y over 2 squared, and then remember dy. And then from here you can just plug this into your calculator. And I ended up with 50.265. Alright, and that is all for that problem. And there you have it, a review on the washer method and the disc method. I hope that it helped.